Today, I'm going to do a bit more 3D printing myth busting because I've tested if you can improve strength and layer adhesion by applying CA glue or epoxy to the outside of your prints, and I even played around with some continuous carbon fibers. Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video is sponsored by Squarespace. Squarespace is an all-in-one platform that I use to easily provide write-ups and the results of my research. Create your own website by browsing squarespace.com/cnckitchen. More in Squarespace at the end of this video. I've already been testing many different methods to make 3D prints stronger in the past, even up to the point of vapor smoothing ABS and polysmooth. A suggestion that has already been popping up a couple of times is if coating the parts can make them stronger. For this reason, I once again printed a ton of flat and standing hooks, coated them in 2-part epoxy and thin and medium viscosity superglue. After that, I tested them for their strength. So what do you think? Which method, if any, will make the 3D prints stronger? Leave your comments down below. Since I still had a couple of test hooks left over in the end and had a roll of carbon fiber rovings on my shelf for ages, I did additional reinforcement tests with real, continuous carbon fibers. Nothing of that short fiber reinforced filament stuff. And that was really interesting. The material for the tests was Extruder's Silver GreenTech filament, which is a PLA and bio-copolyester compound, but way less brittle than standard PLA and more impact resistant. For each of the coatings I tested, I printed one test hook horizontally on the bed of my original Prusa i3 Mark III's and 3 in the standing orientation to see if they can improve layer adhesion. I used 3 perimeters at 0.165mm layer height and 8 top and bottom layers, which gives me a constant wall thickness of 1.32mm, so we can easily compare both printing orientations. For coatings, I chose the 2 most requested, and that was 2-part epoxy, where I used Hobby King's 15-minute resin that I already been using for ages on other projects. In terms of CA glue, I used 2 different viscosities. One was very thin, where I hope that it nicely flows into the small holes between the layers, and the other one was standard medium viscosity glue, where I expected some smoothing. In order to work with the parts more easily, I put them on a piece of cardboard with a small dab of hot glue. I mixed 2 equal parts of the epoxy resin and hardener and brushed it on the test section of the parts in a more or less equally thin layer, and then put the parts on the side for curing. The other parts were just covered with a thin layer of CA glue that turned out to be quite irritant for my eyes in the amount that I used. So if you want to do something like that, preferably do that outside. I've had a big roll of carbon fiber rovings on my shelf for quite a while, and even though this is not the main topic of this video, I thought it might be interesting to find out how much they can improve the strength of my test hooks over just a normal coating. I made another batch of 2-part epoxy, brushed it on the hooks, and then submerged pieces of the carbon fiber in the critical areas. In the one case, they were ideally oriented in the direction of the load. In the other case, I just wound them around the part, which should be the direction where they don't add any strength. As I already said before, since this is not the main topic of this video, I didn't investigate that in greater depth, but if you'd like to see more of that, let me know in the comments and leave a like. Also, check that you're subscribed to the channel to not miss any other investigations in the future. Since YouTube is currently a bit weird with subscriptions, make sure that you've also selected the bell to get notified of new videos. All parts were left to cure for a couple of days. The CA glue only left a slightly dull surface on the parts and didn't seem to have added any material or smoothed them significantly. The epoxy cured to a shiny, slightly yellow layer, adding at least a couple of tenths of a millimeter in thickness. I then put them one after the other on my DIY universal test machine and loaded them at a constant speed until they failed. Let's at first test the reference parts that were not treated with anything. The hooks printed horizontally on the bed failed on average at 53 kilograms of load. In comparison to standard PLA, the GreenTech filament from extruder yields a lot, which makes the part a bit more predictable. The standing hooks failed on average at 24.4 kilograms of load, which is roughly half the strength of the lying specimens. Let's now continue with the test specimens that I treated with a thin superglue. The one that was printed on the bed failed at 58 kilograms of load, which is 10% more than without the treatment. I know that there is not a big statistic behind that, but even considering the scatter of our reference, this value is significantly above those values. But I think the more interesting question is if the superglue creeped into the layer gaps and helped with layer adhesion. On first glance, the failure mode didn't really look differently. On second glance, with an average failure load of 23.6 kilograms, the strength wasn't better and basically on the same level as without the glue. Kind of unfortunate, but let's see if the medium viscosity glue or epoxy performed differently. Similar to the low viscosity glue, the horizontal hooks treated with the medium viscosity CA glue were able to bear around 10% more load than the reference and failed at 58.9 kilograms. Unfortunately, layer adhesion doesn't seem to be improved, because the parts once again failed at exactly the same load as the reference. Next, let's take a look at the hooks that I coated in epoxy and where I really have high hopes, because at least the additional material on the outside should improve strength. Let's start with the hooks that I printed lying. Have you heard the crackling noise? Probably due to the higher stiffness and brittleness of the epoxy, the outer layer started cracking during the test, even before failure. And also the failure load with 54.4 kilograms was just slightly higher than the reference. So no real improvement there. The strengthening effect of the additional layer probably didn't come into play because of the cracks. This is how the standing hooks performed. With 22.7 kilograms of failure load on average, they were even 7% weaker than the reference. They cracked where the epoxy was applied, and we can again see cracks in the surface. The reason why the strength was even lower is probably because the cracks that were formed during the loading acted as additional sharp stress risers, and the small shocks that occur when they form might have just been enough to start a failure in the plastic. So epoxy itself doesn't significantly reinforce 3D prints and can even be detrimental. But how about the carbon fiber reinforced ones? For those, I also use the same resin to hold the strands in place, but in this case, the fibers will take most of the load. In comparison to the short, cut fibers that you find in special filaments that are mostly only around a couple of 100 micrometers long, the rovings I use are continuous and can therefore transmit way more load if you orient them correctly. The advantage of adding them after printing is also that you are not restricted by the printing orientation and therefore not only add strength in one plane as for example the Markforged printers do. Even though it's a bit of a mess, I can orient the fibers regardless of the printing orientation so that they reinforce the parts perfectly. But let's really find out if we have improved the strength by this method. Let's start with the hook where I added the carbon fibers in loading direction. Well, the part failed at 32 kilograms, which is almost 30% more than the reference. At a closer look, we can see that it failed directly at the location where the reinforcement ended. Damn. The rest of the epoxy layer doesn't show any sign of failure yet, so the part probably could have been much stronger. Probably worth revisiting, or what do you think? In order to finish that up, let's take a look at the parts where I just wound the fibers around the critical section, so the worst orientation possible. This one also was stronger than the reference, but ripped right through the section where the fibers were, and I assume that the additional strength only was due to the large amount of additional material and not the carbon fibers themselves. Alright, so what have we learned? First, I'm a bit underwhelmed by these results. None of the glues alone seem to have improved strength a lot. The CA glue improved the strength of the parts printed on the bed a little, but no change in layer adhesion. Epoxy alone even seems to have a negative effect on the strength, at least with the one that I used. On the positive side, I think I've at least busted this myth that has been around for a while. More importantly, I think that there might be quite some potential in the continuous carbon fiber reinforcement technique that might be worth another video. If you have experience in that field or a good technique in mind, please let me know. The detailed test results are available for my Patreon supporters and YouTube members, but if you only want to take a second look at the graphs, then check out my website that I built with the easy tools provided by today's video sponsor Squarespace. Squarespace is the all-in-one platform to build a beautifully looking online presence. They have a ton of professional templates for you to start with and free stock photos for quick customization. Their online editor is so intuitive to use and helps you create and maintain your website even with no initial experience in that field. If you have a business or just want to share your latest hacks, prints or research in a professional manner, then start your free Squarespace trial today at squarespace.com/cnckitchen and use code cnckitchen to get 10% off your first purchase. If you don't like standing in front of a camera, but still want to review printers and other tech, Squarespace is a great tool to create a professional website or blog that can even help you earn some money with your hobby. So try out Squarespace 2 weeks risk-free by browsing squarespace.com/cnckitchen and let them know who sent you by using code cnckitchen for 10% off upon checkout. Thank you Squarespace for supporting this channel. Thanks for watching. I hope you have learned something new today. If you did, then please leave a like and make sure that you subscribe for future investigations. If you want to support my videos and research, then consider becoming a Patreon or a YouTube member or help me out in other ways. Also, check the rest of my video library because I'm just about to reach 100 videos and there is a ton more for you to watch and enjoy. I hope to see you in the next one. Auf Wiedersehen and goodbye!